We treat cash like a public utility that costs nothing to use. But physical money carries an invisible tax. The average American makes 48 payments a month. Only 14% involve physical bills or coins. While that cash share shrinks, the massive infrastructure required to process it remains the exact same size, forcing us to pay full price. This 14% utilization rate now carries the full weight of a heavy, centuries-old physical network. Economists point to a specific mathematical threshold where this system officially breaks down. It is called the penny event horizon, the exact moment when fixed maintenance costs eclipse face value. The copper, zinc, and manufacturing labor required to mint a penny costs more than 1 cent. The raw physical matter exceeds its economic worth. The $1 bill is rapidly approaching this same mathematical breaking point. As fewer people use paper money, the overhead cost to print, move, and secure a single dollar bill rises. When it costs more to handle a dollar than the dollar itself is worth, maintaining the cash supply becomes a massive institutional loss. Physical currency is a heavy industrial logistics problem. Before a dollar reaches your wallet, it requires massive manufacturing facilities to cut and inspect the paper. Moving that paper across town requires armored vehicles burning diesel fuel and employing armed guards. Storing it overnight demands expensive real estate and immense thick steel vaults to ensure physical security. Using it at the retail level requires proprietary hardware and thousands of hours of manual human labor to verify, tally, and reconcile. Relying on cash means paying a permanent premium to support a slow and highly inefficient supply chain. Digital networks replace that entire supply chain with cryptographic tokens. Trust is embedded directly into the math, allowing endpoints to connect instantly and weightlessly. You do not need an armored truck to move a data packet. There are no steel vaults to build, and no hourly wages to pay for manual counting at the end of a shift. This chart illustrates the difference in bottom-line economics. The flat, fixed costs of handling physical cash remain high, while the marginal cost to process one additional digital payment approaches zero as the network scales. For local retail shops, this math becomes impossible to ignore. As their cash volume drops to single digits, the fixed costs of maintaining a physical register destroy their profit margins. Small businesses will organically opt out of that physical overhead. The transition will happen because local shops simply cannot afford the luxury of handling paper. Decoupling value from physical paper accelerates global economic velocity. Smart contracts release rent to landlords the second specific conditions are met. Cross-border remittances settle in seconds between two mobile phones, completely bypassing traditional banking middlemen. This diagram maps the transition to money as an API, a programmable service layer built on settlement rails and tokens. Apps pull directly from this layer, embedding frictionless value seamlessly into housing platforms, public transit gates, and global commerce checkouts. Programmable money turns capital into a fluid tool that moves at the speed of data. Central banks and policy think tanks do not dictate this timeline. Physical matter lacks the velocity required by an interconnected global economy. Every second, billions of quiet, decentralized, cost-efficient digital interactions power the economy. The fate of cash was decided by the mathematics of operational efficiency.